Hey, we have a video now on multiplying matrices, and there's a few small informational bits that you need to get. Um, so if we look at this, we have two matrices up there. We have matrix A, which is matrix A, and we have matrix B. Now let's look down here. Example 1. Example 1 says evaluate A times B. Well, in order to multiply those, you first have to determine whether or not you can actually multiply those at first. So first step would be to identify the dimensions of matrix A, which is a 2 by 2. Identify the dimensions of matrix B, which is also a 2 by 2. And then from this step, we have to look at these numbers here. Do the columns here match the rows here? And in this example, the columns do match the rows. So we are able to multiply matrix A times matrix B. Now, the neat little thing about doing this is when you multiply those two matrices together, you're going to get a matrix in your answer that is going to be a 2 by 3 matrix. Did you see that right there? This number and this number determine the rows and columns of your answer. So right now you know that it's going to have 2 rows and how many columns? 3 columns. So when you multiply those two, you'll just fill in those blank spaces there. This next slide I'm going to show you, we're coming back to this part right here. We're coming back to example number 1 because we're actually going to multiply those. But I want to go to the next slide to show you what happens on this next slide. So you may want to save some space on your paper to complete the rest of this work, or you may want to just maybe write example number 2 down here in one moment after we finish example number 1. Example number 2 says evaluate B times A. Now, that's kind of a big difference here because the previous example said A times B. And why is it a big difference? Well, let's look at B. B is a 2 by 3 matrix, and A is a 2 by 2 matrix. Do the columns here match the rows there? And no, they don't. So since those columns and rows do not match, you cannot multiply B times A. So you can't evaluate example number 2. All right, let's go ahead and evaluate A times B. Let's go ahead and do this. Okay, so what we're going to do is let me rearrange some of this stuff here so we can get a little bit more room to do some work. So when we multiply A times B, we know that we're going to have a, I thought we said a 2 by 3 matrix. Okay, so first off, what we're going to do is we're going to look at this row. We're going to look at that row, and we are going to imagine, let's not imagine, let's actually do. We're going to take this row, which is 2 and 3, and we are going to multiply it by each and every single one of those columns up there. So first off, 6 and negative 3. Well, let's deal with that one first. So if we look at what we're going to do is we're going to go 2 times 6, 3 times negative 3, and whatever we get there, we will be adding those together. 2 times 6 is 12, 3 times negative 3 is negative 9, add those together, we're going to get 3. Well, where do we put that in our final answer? The only suggestion that I have to think about is, you notice how this is top row, and this is first column. So top row, first column is what we're going to put there. 3. Okay, let's do a couple more here, and you can get the idea of kind of a pattern. If you can follow the pattern, I think you'll get it. So we're going to have 2 and 3, and here we have 4 and 1 now. So 2 gets multiplied by 4, and 3 gets multiplied by 1. 2 times 4 plus 3 times 1. 8 plus 3, 11. So we're looking at top row, middle column. Top row, middle column is right there. And we have 2 and 7. 2 gets multiplied by 2. 3 gets multiplied by 7. 4 and 21 make 25. Top row, third column. Top row, third column. And I know my brackets up here look like I was going to do a 3 by 3. I just got a little carried away there. Got pretty excited there. We're going to be multiplying some matrices. I was getting pretty amped up. Maybe I wanted one more row in there, do a little more math. And now let's look at the bottom. The bottom now. Well, we're looking at, let's see, here we have this. So we have 5 and negative 2 on the bottom. And we're going to deal with the 6, negative 3 first. So 5 multiplied by the 6, negative 2 multiplied by the negative 3. So 5 times 6 plus negative 2 times negative 3. Bottom row, first column. Bottom row, first column. Get to 36. And now we're done there. Let's move on. 4 and 1 in the middle. Once again, 5 times 4, negative 2 times 1. 5 times 4 will give us 20, and negative 2 times 1 will give us a negative 2, and that should be 18. Bottom row, middle column. Bottom row, middle column. And let's go ahead and figure out what's in that last position. Last position, we have a 2 and we have a 7. 5 gets multiplied by 2. Negative 2 gets multiplied by 7. We're looking at 10 and negative 14. 10 and negative 14 make negative 4. Bottom row, third column. Bottom row, third column, negative 4. Alrighty, just made some progress there. Let's check here. Remember, this was a 2 by 2. This was a 2 by 3. We could multiply those because the inside numbers were the same. And let's look here. 2 by 3 should be our final answer. Is that a 2 by 3? By golly, it is. So there we go. 2 by 3. Final answer. I know there's a few steps to this, but it's all basically the same part. Let's evaluate this matrix multiplication. Well, if we look here, we have, well, first off, determine if we can actually do that first. We have a 3 by 2, and here we have a 2 by 2. Those are the same, so our final answer will be a 3 by 2 matrix. So that means 1, 2, 3 rows, 1, 2 columns. All right, and now we just go about through this process. So if we look, first off, we're going to go 2 times 4 plus 1 times 2. We know what 1 times 2 is. 2 times 4 is 8, plus 2, that's going to be 10. So this was top row, first column, top row, first column. Let's look at the next one. We have 2 times 3, 2 times 3, and then we have 1 times 0. 2 times 3 is 6, plus 0 is 6. So we have top row and second column. Top row, second column, you put a 6. Okay, moving on. Let's go middle row and first column. Middle row, first column, negative 2 times 4 plus 0 times 2, which is 0. I don't need to really write that down. Negative 2 times 4 is negative 8. Middle row, first column, negative 8. And we are cruising right along here. All right, so now let's move from the first column to the second column. We're going to take negative 2 and multiply it by the 3. Negative 2 times 3. And we know 0 times 0 is 0. Don't really need to do that at the moment. Negative 2 times 3 is negative 6. There we go. That was middle row, second column, and that's why negative 6 went in the middle row, second column. And now let's move on to the third row, first column. So now we're looking at third row, first column. 0 gets multiplied by 4 to give you 0, and 3 gets multiplied by 2 to give you 6. That would be third row, first column. And now let's look here. Now we're going to go second column now. Third row, first column. So 0 times 3, 0. And then 3 times 0, which is also 0. And now, since we were in the third row, third row, second column, what can I say? What can I say? Finished. That's what I can say. So there you go. Matrix multiplication. The key here, make sure those two middle numbers are the same, and then you should be able to multiply those. If they're not the same, you just say you can't multiply them. Any other questions for today? Questions? No other questions? Then that's the day. Thanks very much.